Hey everyone, welcome to my channel. In this video, we are going to learn how to use motion capture using a simple webcam. Here you can see that we are using a video for a demo and the person is dancing and we have taken their pose and their landmarks and we have imported it into Unity. So here you can see the same dance and the same animation being played. Of course, it is not linked at the moment. It's not real time. We have extracted the animation in a file and then we have imported it into Unity. So we will be going through step by step how we can do this, how we can achieve this. Here you can see the final result. This is the animation that we have imported. And if we look at it in 3D, you can see that's how it looks like. And if we look at the game, you can see this is what it looks like. So this is what we are going to learn today. It is very exciting, so stay tuned. Today's video is sponsored by JLC PCB. JLC PCB provides high quality production of your custom PCB designs. They have their own factories with fully automated production lines to provide high quality and consistency that is used by over 800,000 businesses and innovators. Their fast and reliable service along with 24-hour customer support makes it an ideal choice for rapid prototyping of your ideas. Simply add your Gerber file to their website and select the desired parameters and see the magic happen. So visit their website and order your PCBs today. So here we are in our PyCharm project, and the first thing we will do, we will go to File and we'll go to Settings and we will click on the project name, which is Motion Capture. And then we will go to the interpreter and we will add. So settings and add, and we will use the existing environment and we will hit OK. So I'm using Python 3.7. If you want to use a later version, you can do that as well. Now, what we need is the installation of our packages. So we need to install CVZone. That will install the NumPy and the OpenCV. And then we need media pipe. So we are going to install that as well. So these are the two libraries that we want. Now make sure for CVZone, we need version 1.5.5 or onwards. So before this, it will not work. So make sure it's 1.5.5. Okay, CVZone installed and media pipe is installing. Until then, we can have a look at our video, which we have in our motion capture project. So we can open this in our Explorer. And it is right over here. So this is the video from which we are going to capture the animation, the motion over here. And you can see the camera is quite still. It is moving a little bit, but most of it is still. So what you want is an actual video which is still. You don't want the camera to move because the camera movement will also be saved in the animation. So you don't want that. So those are some good moves. So we will try to copy those into our Unity project. So we have our video and the packages is also installed, the media pipe, and then we will go to new and we will add a Python file. Let's just call it motion cap. So here we are going to import our packages. The first one we will need is the OpenCV package, which is CV2, and then we are going to import from CVZone. So we will write from CVZone dot pose module import pose detector. So basically we are going to find the pose, and from that pose we are going to get all the landmarks. We have 33 landmarks that we are going to get, and we will take them to our Unity project. Now, how do we do that? We are going to save it in a text file, and from that text file we are going to create that animation in the Unity project. So what will that text file look like? So basically we have 33 different landmarks. So this means we have the X, Y, and Z multiplied by 33. So we have a total of 99 parameters. So all these 99 parameters will be in a single line. So it will look like this. So it will be x1 and then y1 and then z1. So this will be the landmark number 1, and then again we will keep separating with the comma, and then it will be x2, y2, and then z2, and so on. So this is how we will put it, and it will go till the end, which is 33 landmarks. So each line will represent one landmark list, and then we will have a list of these different landmarks. So let's start by opening up our video. So we will create an object. So we will write cap equals cv2.video capture, and we are going to give in the video. So we will write here video.mp4. mp4, it is directly here, so it should run. And then we have to write while true, we are going to write success and image equals cap.read. So that will read, and then we will display it cv2.imshow, and let's just call it image, and we will display our img, and then we will write cv2.wait key. W is small and K is capital, and we will give it 1 millisecond delay. So let's just format that, and let's right click and run that. There you go. So you can see it is running quite fast, but as soon as we introduce the pose detector, it should run much slower. So let's create the detector. So detector equals our pose detector, and do we need to give in any parameters? Well, you can, but in this case, I don't believe we need to give in any parameters. So that should be it. And then using this detector, we are going to write detector.findPose, and we will give in our image, and this will return us an image. Then to find the landmarks, we are going to write lm_list, which is the landmark list, and the box info, bounding box info equals detector dot find position, and we will give in our image. So these are the two lines we have to write to get our pose landmarks. So let's run that, and there you go. So now we are getting the bounding box, and we are also getting all the points that we require. Okay, so once we have this, what we do need to do is to check first of all if there is a body detected or not. But in this case it is detected, but still we need to write that information. So we will write that if our bounding box info, or you can even write lm_list, it's the same thing, if it is not empty, then we are going to do something. So that something is basically sending all the lists to our file. So what we will do is, first of all, we are going to create a file name, and we will call it lm string. Actually, let's put it inside the bounding box info. We will write here lm string, and we will keep it empty. So this string will basically have all the 33 points in it. So we will loop through all the points, and one by one we are going to add it to our string. So we will write for lm landmark in landmark list, we are going to write landmark string plus equals, we are going to write lm, should we convert? Yeah, we should convert it into a string. So we will write it like this. But this lm is not actually a single value. It contains different values within it. So if we print that out, let's just see what does lm give us. So let's run that. And there you go. So we can see here, LM is giving us the number of the, what do you call, landmark. So it is up to 32. It will start from 0 to 32. So you have 33 values. And then you have X, Y, and Z. So we need to store all these values. So what we are interested in are these three values. We don't care about this. So we will write these down. So here what we will do, we will take in the first value. So let's remove the comment. And here the LM we are going to put in our first value. So not the 0 value, the first value. And then we are going to, actually, you know what? Let's just write an F string. It will be easier. Let's write an F string. And here we can put this in brackets. Okay, and then we can add a comma. So we will have comma separated values, also known as CSV. And then we are going to write LM, then we will write 2, and then we will write comma again, and then LM, no, my bad, we will write a bracket and then LM, and we will write 3. So these are the values that we need. But for the Y value, the problem is that OpenCV uses the, what do you call, the starting points. OpenCV uses starting point from here, from the top left corner, but Unity uses the starting point from the bottom. So we need to change the Z, sorry, not the Z, the Y. So the Y should not be 0, 1, 2, 3, 4. It should start from here, 0, 1, 2, 3, 4. So we need to make it opposite. So here we are going to write, we will check the size of our image. So image dot shape at number 0, that is the height, minus LM2. So it will reverse it. So yeah, that is what we need. And then what we can do is we can create a list here. Let's just call it position list, and the position list will be empty. So whenever we are getting a position list, we will append it to our, whenever we get the LM string, the complete string, we will append it to our position list. So here we will write, if we have the bounding box, yeah, then we are going to write position list dot append, and we will append the LM string. So each time it will refresh the LM string, and then it will append. So if there is a, what do you call, body detected. So that is good. So what we can do is we can print the position list to see what is happening, and then we can export it to a file. So we will write here position list, and let's run it. There you go. Okay, what is happening? Okay, we have multiple prints. That's why it is showing weird values. So there you go. So now you can see, actually it's hard to tell what is happening. What we can do is we can print the length of it, so we will know what is happening. So each of these LM string is basically a frame of animation. So you will have, let's say, 100 frames of animation. So these are the number of frames we are getting. So you divide that by 30, and that's 30 FPS. If you're using 30 FPS, then that's how many seconds the video will play, or the animation will be. So here you can see we have a total of about 327 frames. So this is what we are getting. So now what we can do is we can save this into a text file whenever we press the S button. So we can store this into a key, and we can write that if key equals ORD and S, which means we have pressed the S button, then we are going to store it in a file. So we can write here with open, and then we are going to write the file name. So let's call it animation text, or let's call it animation file. Okay, this is annoying. Animation file dot txt, and then we are going to give it the writing permission. So we will write W, and then we are going to write it as F, and then we are going to write that our F dot write lines. Now we are going to write the lines. Now we need to loop through all these values and then insert it. So we need to loop through all the position list and insert it one by one in a different line. So how can we do that? Basically, we can write percentage S, and we will write a new line, and then we are going to write percentage item for item in position list. So what this will do is it will loop through all the items and then it will put them in the line one by one. So that's how simple it is. So let's run that, and if we press the S button and we stop it, there you go. Now we have the animation file, and you can see here these are all the numbers that we have. So the first three are the X, Y, and Z. Then again we have the X, Y, and Z, then X, Y, and Z, and so on. Is this correct? It doesn't seem correct. There is a comma problem. So we didn't add a comma. So there needs to be another one over here. So at the end over here, we need to add a comma. So if we run that again, and then we press S and we stop and we open it, and there you go. So now it looks much better. There you go. So these are our values. So this is X, Y, and Z, X, Y, and Z, X, Y, and Z, and so on. So here you can see we have 38 frames. So we can keep rolling it, and then we can take this file to our Unity project. So let's run it and save it. So we will let it run till the end. And we will press the save button at the end. Okay, I believe we are close, and there you go. So how many frames did we get? 314. The total were 327. So I think that should be fine. So now we are done with our Python parts. Now, whenever you want to use a different video, just change the video over here and it will create an animation file. So if you want to change the name, you can add a counter here as well. You can check how many files are there. You can put it in a folder and you can do lots of different things. But for now, we are going to go to Unity, and then over there, we are going to import this. So here we are in the Unity project, and you can see we are about to create a new project, and this is version 2020.3.25 F1 LTS. So this is the one we are using, and I think if you use any other, it should work. It's very basic, so it should not be a problem. So here we are going to write the name. So let's call it motion capture, and we will create our project. So here in Unity, we are going to go to our scene, and what we will do is we will create some points, and then we also have to create some lines, but we will do that later on. For now, we are going to create two things. The first one will be, let's just right click and we will create empty, and we will call it manager. So this manager will have the script for the animation. So we will write down, we will import all the, what do you call, landmarks, and then we are going to push them to our points using this manager script. So I will tell you later on what exactly will be in our script. But to run the script in Unity, we do need to attach it to an object. So that is an empty object in our case, and we will call it manager. So it's nothing fancy. And then we will also create another empty object, and we will call it points. So this will have all the points, or you can also name it, let's say, body, and within the body we have all the points. Let's just say that. And here we are going to right click and we are going to create, what should we create? Let's create a sphere, and let's just keep the name same, and we will change the size of it to 0.2, and then 0.2, and then 0.2. So this is our sphere. If we press the F button, it will take us to the sphere. And this is right now, it's what you call white in color. We will like to make it red. So what we can do is we will right click here and we will create, we'll create a material, and this new material, we will give it a red color. There we go. We will close it and we will simply drag the color on top of it. That's it. So now it is red in color. So this is basically one of the landmarks. What we need are a total of 33 landmarks. So this will be sphere number 0, and then we will copy and paste. So if we keep pasting, we will see that we can get to 32 because we are counting 0 as well. In fact, we can rename it to 0, and then from 0 till 32 we have 33 different spheres. So all of them are in the same position, so we don't need to worry about that because the positioning will be coming from the file. So once we import that file, we will have the positioning as well. So let's actually go back to our file, and the next thing we will do, we will copy and we will paste it here. So you have to go into the Explorer. So here you will go to assets, and in the assets you are going to paste the file. So this is the animation file.txt that we created, and now if you go here you will see that it is here. You can simply drag and drop as well, it should work. So this here you can see this is the file that we have. Lots of crazy numbers. Anyways, so now we need to get these 3 points and we need to put it on one of the these spheres. So now to grab the information from our animation file, we need to create an animation script. So we will right click and we will create a C# script. We will call it animation, let's say code, and we can open that up. Now, even if you are not familiar with C#, this should not be an issue. It's pretty much similar to Python, what you have seen. A little bit difference here and there. I will mention what exactly are the differences. And the code that we are going to write is very small, so it should not be anything difficult. So this is basically our script now, and it has a class by the name animation code. So what exactly is happening? So whenever you create a script, it's basically a class. So this name here, animation code, and the name over here should be exactly the same. It cannot be different because the file represents the class. And what this class is doing, it's inheriting from Mono Behavior. And Mono Behavior is a class that is already developed by Unity, which has all these functionalities like start and update. So you don't have to put the loop anywhere. So this will happen, this code will run in the start, and this code will run continuously with the loop. If you remove this from here, you will see that this will be problematic. This will not run properly. There you go. So anyways, so let's go back, and here what we are going to do we are going to write down our, let's just write it here. So we are going to write public, which means that it can be accessed from outside. So it's not just from this script, other scripts, or we can access it from outside as well. So we are going to write public game objects, and we will need a lot of game objects, and we will call it body. So what this will do is it will create this list of game objects and it will store it in body. So if we save this and if we go back, it will reload the script. And if we now we will attach it to our manager. So the animation script, we will grab it and we will attach it to the manager. We will drop it. And here now you can see in the animation code, you can see there is a variable called body. Because it is public, it is showing us over here. So here, this is our body list, and this list is empty right now. So what we need to do is we need to put 33 elements here. So we will write here 33, and this will generate 33 objects for us. So you can see here are up till 32. So what we need to do now, which is a little bit time consuming. So we need to take each one of these and place it here. So sphere 1 to sphere 0 to 0, element 1 to sphere 1, and so on. So I will do that now. 3, 4, 5, 6, 7, 8, 9, 10. I know it's a little bit time consuming, but you only have to do it once and then it will run forever and ever. So 14, I'm pretty sure there must be a better way to do this. So if somebody knows that, please let us know in the comments, and next time I will try that out. So 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, and 30, and 31, and 32. Oh, 32 I missed. There you go. So now we have all the objects that are linked. So now when we go back to our script, we can actually relate to each one of these points, and we can tell it go to X, Y, and Z position. So that is why we need the access of these objects. So let's go back. So now our file is basically in a list, and this list consists of strings. So what we need to do is we need to retrieve this information in terms of list, and then with each element of that list, we will convert it into numbers and use those numbers on our points. So here what we will do, we will write here that we can keep it private. So we don't need to write here private. So we will create a list, and that list has to have a certain element of type. So this type we have to define here. So we will call it string. So this is the string type, and what we will call it lines. So we are creating a list of strings and we are calling it lines. So each line we will grab one by one and then we will convert it into numbers. So now we need to get our text file. So we will write here lines equals system.io dot file dot read lines, and then we have to give in the location. The location will be we have to write double quotation assets slash animation file dot text. So it has to be exactly the same. And then what we need to do is we just need to convert it to a list. To T needs to be capital, to list. So if the list is not working, it is because we didn't import. We didn't import the library that is required. So we have to use system link. So we will click on that and it will import system link. So you can see here, this is our library imported. So now you can see the to list does not give any error. So let's just save it. And here what we will do is we will write print, and then we want to print lines at 0. So we just want to see if everything is printing properly or not, and whether we are importing everything correctly and it is running properly or not. So we will save this and we are going to move it aside, and then we will go back here. It will reload the scripts and we are going to run it. So now it is running, and if you look at the console, this is the console over here. It is maximizing on play. Let's not do that. So let's just put it back here. There you go. So now it's showing us the first element in each iteration. So you can see these are the numbers that we are getting. So for example, what we can do is we can bring our code back here, and what we can do is we can parse it and we can get the actual values. So how can we do that? To do this, we have to write here. So we will go one by one. So here we will write that we are creating a string and we are calling it points, and that is equals to lines at, let's say, 0. So we are just talking about the first line. We will add a counter later, but for now we are just talking about the very first lines. Lines at 0, and then we are going to write dot split, and the splits we want by a comma. So don't forget the semicolon. We need that in C#. So what we can do now is instead of printing the complete line, we can print, let's say, the string. What did we call it? We called it points. So points at, let's say, 0. So the first points, it should be, did we open the file? Okay, it should be 579 here. So you can see it should be 579. So let's run that. Let's just save it. We will go back and then we are going to run it. There you go. Now we are getting to the exact value. So it is 579. So now all we need to do is we need to convert it into a number, because right now it is actually a string. So we need to convert that into a number. So we can write here float dot parse, and then we are going to write points at 0. So that will convert the points, and then we are going to save it in, let's say, float, let's say x equals this. Now you might be asking, wait, these are integers, why are we creating floats? And I will tell you why. Because here, if you see, right now the position is 1.8, and here the position of y is 3.4, then here the z is 0. minus 0.5, something like that. So these are not big values, but if you look at your text file, those are big values. So let's go to our project, and this is our animation file. So here you can see these are big values: 579, 3, 239, minus 53. So all these are big values. So what we will do is we will divide them by 100. So that will give us values that are similar to our scene. So 1.8, 3.4. So 500 will become 5, 300 will become 3. So that will be easier and it will be similar to what we have seen. So let's go ahead and do that. So here we will divide this by 100. And the same thing we will do with our y and z. So this will be y and this will be z, and this will be point number 1 and point number 2. And what we can do is now we can take all of these points and we can put it on our body. So on the first sphere. So here, for example, we can write body at 0 dot transform. So now you might be saying, wait, what is this transform? So if we go back to our Unity project, so if we click on our sphere, you can see there is a property called transform. So within that transform, we have position, rotation, and scale. So if we want to change any of those, we will write transform dot position dot x is this, then dot y is this, and dot z is that. So that's basically how we can write. So we will go back here and we are going to write dot transform dot local position. So if you write position, it will be global position, but right now we need the local position. So we will write local position equals new vector, vector 3, and then instead of writing dot x and y and z, we can simply write the first value as x, y, and z. So that's how we can give in our value. So if we save this, and if we go back, you are going to see that one of the spheres will now start moving. Actually, let's move this code on one side and let's make this bigger and let's run it. So something happened. Yeah, so you can see one of them moved on the side. So that's a good start. It means it took the value and it moved it. But it's not constantly moving. Every frame, the position of that sphere is supposed to change, but it's not changing. Why is that? The reason is because we are always taking from line number 0. So that is not how it's supposed to be. It should go to line number 1, line number 2, line number 3. So every iteration, it should go to the next line. So here we are going to write a counter, and here we will write the counter equals, we will call it integer counter equals 0. And here we will write counter plus equals 1. So now if we run it, so this is the counter, we can remove the print. We don't want that. And now the points will change. So let's run that and see if it works. And there you go. So there you can see, let's just see it from the scene. And it is giving an error because again, the counter, we did not stop, it keeps moving. So we need to say that if the counter, if counter equals lines, so based on the text file, how many lines do we have? How many frames do we have? So in our case, we had 317 or something. So we need to check lines dot count. So it is like writing length of a list. You are writing lines dot count. It will give you the number of elements it has. And if that is the case, then we will write counter equals 0. So it will reset the counter and it will keep playing it again and again. So at least we will not get an error. every time. So let's run that. There you go. So if we go to the scene, you can see one of them is moving, and it is moving really fast. So there you go. So one of the spheres is moving, and now we need to do it for all 33. So how can we do that? Now you might be thinking, okay, that will be difficult, but it's just a for loop. So here, if we go back to our code, here we need to add a for loop in which we will change these numbers. We will change these numbers, and we will change these numbers as well. So here we are putting on the first sphere, then we have to put it on the different ones. So we will write here for integer I equals 0. We are going to write I is less than 32, less than or equals to 32, then I plus plus, because we have total 33 values, so we'll put equals to as well. And then we are going to write all of this within our for loop. And over here, instead of the 0 value, what we will write is 0 plus I multiplied by 3. And the same thing will happen with the second one. So 1 plus I multiplied by 3 and 2 plus I multiplied by 3. So this will be 0, 1, 2, and then this will be 3, 4, 5, then 6, 7, 8, and so on. So that's how this will go, and this will be basically I. So this is the sphere number. So each basically I is basically a different landmark, and it's a different sphere. So let's just save that. That's how simple it is. We just add a for loop and change a few values, and that's it. Let's just give it some space and make it same. There you go. So let's go back and see if it will work. So what happened? Okay, there you go. So something is happening, but it's not very clear what's going on. But that's okay. We can fix stuff. So first of all, let's try to find what is happening. There you go. So here you can see that it looks like a human moving, but it's, first of all, it's very fast. We need to slow it down. There's no doubt about that. So let's just bring it back. And because we are just reading from a text file and we are putting the values there, that's why it's really fast. So here what we can do is we can write, first of all, let's include the library that has the pausing. So we will write using system.threading, and we will go down and we will write here thread. Is it thread? I believe it is thread.sleep. Thread.sleep, and we will give it 30 milliseconds. So let's save it and move it aside, and then we are going to write, we are going to play it. So let's go back to our scene, and there you go. Now you can see it is looking like a person dancing. It looks good. There you go. He's coming in front. You can see him dancing, and that is good. Maybe we can play around with the camera. The position of the camera, we can go back and forth. So in the game, we can see here, if we go back and forth, and if we go up and down, we can change this. There you go. Actually, we can put a plane as well. So what we can do is we can go here and we can right click and we can create a cube, and we can make it really big, by stretching it out. So we can click on the scale. Which one is that? This one is the scale, and we will increase it. We don't need the Z as much, but we need the X and the Y. Sorry, the X and the Z. The Y we don't need to increase that much. So we can click on that. There you go. And as I mentioned, we don't need the Y as much, and we can push it down. There you go. So let's see the game now. There you go. Let's run it, and hopefully it will look better. Yeah, it is kind of better. First of all, let's just move the camera up a little bit. So let's move it up like that, and even the X. I think it's too close, the camera position. So the perspective is this. With orthographic view, it's a little bit better to see. So we can move it like that. So what we can do is we can basically move it a little bit back. Okay. So here the camera, we made it orthographic. We changed the size to 9. And these parameters, we can click here and copy component, because when we press stop, it will change back to the old values. So we need to go to the main camera, and we will click and we will paste component values. So now these are the values, and then we will change perspective to orthographic, and then we will change this to 9. There you go. So if we play this now, we will have similar results to what we saw earlier. So there you go. So this looks much better. And we don't even need the cube now. So what we can do next is basically creating the lines between these, because right now it's not looking that great. So we will go to body and we will create an empty object, and this we will call it as line. Let's push it up, and actually it will not be a line, it will be lines. So we will be multiple lines, and inside that we are going to create. So we will go to effects, and then we will create a line. So this will be our first line, and what we will do is we have to define the line from which point to which point does the line go. So for this we need our media pipe mapping. So this is basically our mapping. What we need to do is we need to connect, let's say, point number 11 to point number 13, then point number 23 to point number 25, then point 23 to point 11. So we need to define all these parameters. So how can we basically connect these? So to connect them, we simply will create a new script, and we will attach it to each line. So we will right click and we will create a new script, and let's call it line code. So we will open it up, and it will open up in our motion capture project. There you go. And what we need to do is we first of all need to create our line renderer. So we are going to write line renderer, and then we will call it line renderer. So this is our line renderer, and then we need a transform for our origin and our destination. Then we need the transform form for our origin, and then we need the transform for our destination. So what does that mean? What are we trying to say? Basically, each line will have a starting point and each line will have an ending point. So origin is basically the starting point and destination is the ending point. So what we will do is we will take the objects, we will take the sphere, and then we will take its transform, and we will tell the line to attach to that transform, so to that location. So that line will attach to one sphere and it will attach to another sphere. So that's how we will have our line. So this is our transform for the origin, and then here we will write that our line renderer is basically the line renderer of this object. So we are going to attach this code to every line. So it will be attached to all the line objects. So we will say that get component of this object called line renderer. So if you did not understand that, so what we are doing is we are taking this code and we are attaching it to our line. Okay, so now it's on the line and you can see here it's available on line code. Now in this line code, we are asking to find this object, line renderer. Using this line renderer, we are going to give it the starting and the ending transform. So if we go back, this is the object that we are getting. This is the property that we are getting. And then we will define the width of our, what do you call, line. So we will write here line renderer dot start width equals 0.1 f. So when you are writing floating values, you have to write f with it. And then we will copy that and paste, and we will write end width. The end width is again 0.1 f. If you want it to be thicker or thinner, you can change that. We are putting it as a constant value. And then in the updates, we need to constantly update the position, the start and the end position of the line. So we will write here line renderer dot set position, and we have to set position of the 0 element. So the 0 element is basically origin dot position. And I will explain this now. What does this mean? And line render set position 1 is of the destination. So when you are talking about 0, it means starting point. When you're saying 1, it means destination point, the ending point. So we are setting the starting point as our origin position. So our origin position has to be coming from this origin. So we will assign it, actually I forgot to write here public, because we will assign this transform from outside. So it will be one of those spheres. So it is saying wherever this sphere is, get that position and put that line on it. That's how simple it is. So we will write here public, and there you go. We will save it. And yeah, that's pretty much the code that we require. We will push it on the side. And now if you go to the line, and you will see down here, you have two values that you need to fill, two objects. So the origin and then the destination. So here, if we look at our figure, let's do number 11 and 13. So 11 is the origin and then 13 is the ending point. So we can write here, we will take 11 and 13. So we will click on line, then we will grab 11 and paste it on origin, and then 13. And what we can do is we can change the name of this so that it is not confusing. We will put it 11 and 13. So start is 11, end is 13. So let's run that. And hopefully we will see a line. Okay, something is wrong because the line, it's moving, but it is moving way high up there. I'm not sure what is happening here. Okay, so we have the line here, transform. It is number 11 and 13. Is that correct? Yeah, so the origin is not correct. So maybe we are... Okay, maybe we have an issue with the positioning because they are not at 0. So if we click on lines, they are at 0. Okay, the body is not at 0. So let's put it at 0 and 0. So let's run that again. And there you go. So now it's working well. If we look at the game, you can see we can see the line here. So that is good. It's a little bit far though. Let's move the camera a little bit further. And let's push it down as well. Like that. I think, yeah, that is better. So let's copy this. And it is 7.15. So paste component values, and this will be 7.15. Okay, and for the line, we can make it green by creating a new, what do you call, material. And like we did before, we are going to change it to the green color. And then we will go to our line. And here in the materials, we are going to put the new material one. So if we run that now, there you go. So it is green, and you can see we have our, why is it changing? Let's go to the material, and what kind of material do we have? So let's change the type to sprites and diffuse, and let's run that again. Yeah, it's better now. Okay, and we can make it a little bit lighter. Okay, yeah, that's good. So now you can see the line is actually moving. So what we need to do is we need to create all the other lines, and using these values, we have to create all of them. So I will put this on one side, and then I will create all these. So we will create, so first of all, we will write down all of them, and then we will link them. So it will be 12 and 24. Then it will be 11 and 23. Let's go here, 11 and 23. Then it is 24 and 23. 24 and 23. And then we have 24 and 26. 24 and 26. And then we have 28 and 26. 28 and 26. And then we have 28 and 32. 28 and 32. Then it will be 32 and 30. This is 30 and 32. And then we have 30 and 28. 30 and 28. And 29 and 31. Oh, 29 and 31. And then we have 29 and 27. 29 and 27. And 31 and 27. 31 and 27. 25 and 27. 25, 25 and 23, 25 and 23, then 11 and 13 we have already done, 13 and 15, 13 and 15, then 12 and 14, 12 and 14, then we have 16 and 14, 16 and 14. I don't think we have any else. So now we need to link them. So if we go to the first one, we have to change it to 12 and 24. So we will go to 12 and then 24. This is one way. The other way is you click on it, 11 and 23. So 11, and then you click on this and change it to 23. Then here is 24, 24, and this one is 23, 24 and 26, 24, 26, 28, 26, 26, 28, 32, 30 and 32, 30 and 32, 30 and 28, 30 and 28. Actually, we are halfway there. So let's see if it is working fine. So by default, it should all work because the script will run for all of them. There you go. So now you can see it is running fine. And we have all these lines that we require. So we are halfway there, and then we will continue. 30 and 28 is done. Then 31 and 29. Then 27 and 29. 27 and 31. 27 and 25. 23 and 25. 23 and 25. 15 and 13. 15 and 13. 14 and 12. And 14 and 16. There you go. So let's run that, and hopefully we will have all our lines connected in the right order. There you go. We are missing one right in the middle, 12 and 11. So do we have 12 and 11? No. So let's copy and paste, and we will write here 11 and 12. So 11, so 11 and 12. So let's run that again. And there you go. So now you can see we have our animation. So if we go to our scene and we look at it from the front, it is quite good. But if you look at it from the side, there are some issues. There you go. It does not look very good. The animation is very, very different than we have expected. It is expanded. So what we need to do is we need to reduce the Z. So if we go to our code, instead of dividing it by 100 in the animation code, instead of dividing the Z by 100, let's divide it by 300. So let's go back. Because with a single camera, it's harder to estimate the Z. So the Z values are not that accurate. So we are tuning it a little bit to get some better results. So let's go back, and there you go. So now it's much better and it looks much normal compared to before. Still, it is a little bit jittery, but it is at least understandable like what is happening. So there you go. So this is basically our dancing animation that we have imported using the MediaPy package. We exported it into a file, then we brought it in Unity, and then we can see our motion capture being shown here. There you go. That is pretty cool. So basically this is it for today's video. Now what you can do is you can create any other animation using simply a video file, or even you can use your webcam. But as I mentioned before, try not to move the webcam or the camera. That will give you better results. So you can do your own motion and you can bring it here. And there's a lot of different cameras that they can do this. But we are using a normal webcam, which is quite interesting to see the results here, because normally you would use a Kinect, or you could use a depth sensor, or you can use cameras like a Vicon system that have multiple cameras and they can track you with millimeter precision. So in that cases, the animation is quite good. It's much better than this. But here you can see it is a very good start. By using a single camera, we are able to achieve this animation. So we are not far away from some good results, and hopefully with another camera, or having two cameras or three simple cameras, maybe we can even get some better results. So hopefully later on we can try to embed that as well. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up, share it with your friends, write the comments below what would you like to see next, and I will see you in the next one.